experience in the elementary classroom setting, and I served as the elementary science consultant with Edmonton Catholic School Division. And so I'm really excited here. I also am just very passionate about science education and the research behind it. So I have little tidbits to share along the way. And also co-hosting today, or sort of monitoring the chat, is Ted. So I'm sure many of you were in his session yesterday and learned a lot about sort of the architecture and sort of the structure of the science program. So we're going to focus today on the science methods in and of itself. So before we begin, I'd like to do a treaty acknowledgement here. In the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse First Nations, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten. All right. So I'm just going to go on here. Before we begin, I'm just going to do a quick sort of agreement and sorry about that. And that is to position that nothing sort of is, we're working together in a new curriculum, so nothing reflects your abilities. You know, we're here, we're learning together, and productive struggle. So we're going to work through this creatively, collaboratively, and taking risks with some perseverance. So if you have questions, Ted is monitoring the chat. I will pause for a moment. So even if you want to jot something down and you're not sure about something, then you know, you can ask that and he'll bring that up for you, or he'll answer it, or we'll talk about it. And also to situate ourselves is that sometimes this may or may not work. We have different contexts. I see somebody was teaching like grade 1 to 4. So if this doesn't fit with your context, I want you to try and think of how it could. And then if you have questions, of course, we'll definitely help you with that. Okay, so the agenda for today is we're going to look briefly at science as a discipline, because that sort of sets the context of how this curriculum was written. Then we're going to unpack the scientific methods briefly at each grade level as they relate to an investigation cycle that has been laid out. That is where we're going to do a little bit of processing. And we're going to use a program called Lumio. It's pretty straightforward, but it's kind of like Nearpod or Pear Deck, if you've used one of those before. It's kind of a little bit interactive. And then we're going to talk about classroom examples and what it would look like. A lot of that's the question, what does this look like in my classroom? And I often get the question, will these resources be translated into French? And yes, our consultant who works in the French translation, has these and she's working on them right now. So that will be shared out in French. Okay, so the key learnings for today that I'd like you to walk away with is that science uses methods of investigations to build knowledge and understanding of the natural world. Each grade learning outcome and cusps unwraps a deeper layer or focus on a particular investigation step in the cycle. And to understand that students will build on aspects of investigations at each grade level, and it continues to the next. So it's a little bit different, and I'm sure Ted mentioned that yesterday, that we're building that's different than the previous 1996 curriculum. And also that there are criteria to help primary students develop foundational aspects of an investigation that will help carry them forward. So about, you know, assessing these skill areas as well. Just to briefly mention, and I'm sure most of you know, just highlighting that kindergarten does not have a scientific method organizing idea. However, there is a computer science learning outcome. The learning outcome is children interpret instructions in various environments. So that can lend itself to following a sequence of instructions or an investigation as well. Okay, so to begin with, we're going to look at what is science, because that's kind of informing how this curriculum is expected to be carried out. Okay, so to begin with, science is the study of the natural world, and to investigate phenomena. Phenomena are events, situations, or facts in an attempt to explain how it works or why it's happening or what's causing it. So for example, there's a virus that's causing, a respiratory virus that's causing people to be really sick, sicker than the flu. What is it? What's causing it? How does it work? In order to understand it and be able to, problem solve. Okay. So not only is science a discipline that we study in school or in post-secondary or we have researchers doing, it's something that confronts us as citizens on a day-to-day basis. So for example, should I mask, not mask? Should I vaccinate or not vaccinate? Science seems to be changing its mind a lot. We've heard those comments, and sometimes those comments may indicate a lack of understanding of the science process or scientific literacy. Not only that, our students are going to be confronted with issues such as global warming on a day-to-day basis that they're going to have to make informed decisions about. So we have to think of how our students we have our students in 1 year of their educational journey with us from kindergarten to grade 12, and that we are building this scientific literacy for grade 12. And it doesn't just happen in high school. It needs to happen before, just like math or language arts. So if we're going to, and we look at the subject area introduction in science. So, and I encourage you to do that. If you haven't read the subject introduction, it kind of gives a little bit background. So here I pulled out, scientifically literate citizens are equipped to evaluate sources of information encountered in daily life. So that is something we are preparing our students for, not just to do the discipline of science, but to understand it. And if we're going to do that, we should understand what scientific literacy means. So PISA, the Program for International Student Assessment, defines scientific literacy as being competent in 3 areas. So this is what we're working on with our students. And the first part, I think we're probably quite familiar with, is content knowledge or conceptual understanding, as Ted has probably touched on yesterday. And that's the understanding of those science ideas in the various disciplines of science. We have the physical sciences, which was matter and energy, and we have earth and space sciences, which we have those organizing ideas, or biological sciences like our living systems. There's some big ideas in those, or concepts, that we want our students to understand. But science is also procedural, doing something in order to build that knowledge. So there's procedural knowledge, and that is being able to do investigations, and that's where the scientific methods fits in. And we kind of know about that previously, but what's new in this curriculum is something with a fancy name, epistemic knowledge. And what that really means is just understanding how knowledge is built in science, to name and know, as a colleague said to me. So for example, I'm going to use the term theory. There's the lay, or what we call folk term, theory, which is I have a theory. That means I have an idea. But in science, a theory, and understanding that when someone says I have a theory, is knowing that there is a substantive amount of evidence that's indicating a certain idea. So it's really supported by evidence and research and investigations. So for example, our students knowing the difference between what a prediction and a hypothesis is, because they are different. So that's something that this curriculum is also working on as well. So I think what Carl Sagan says here, science is a way of thinking much more than it is a body of knowledge, is where the methods come in, the thinking part of building that knowledge. So a lot has changed since 1996, and I often used to joke about how the old curriculum was written when Beyonce was part of Destiny's Child. And I think science needs to be the core queen bee that it is. So what are some things that have changed? Well, cognitive and developmental psychology on how students learn in the early 2000s has kind of looked at a little bit of a difference in how we approach learning and teaching. We have the definition of scientific literacy from PISA. Science of reading, so the importance of background knowledge on reading comprehension. This is where science and social studies come in. That these subject areas, even in primary, are ways of developing that background knowledge for our students. They give vocabulary, they give the understanding of the way the world works, and of course, the research and science education itself. So our science instruction and resources should reflect these changes that have occurred since 1996. Okay, so let's touch on briefly some of the research, and this is just a quick overview, is so what we're used to from the old resources in the 1996 curriculum is a very activity-based, so a lot of hands-on. So we would have maybe the student learner expectation, the outcome, and then a series of hands-on investigations. So research and science education looked at, well, what ways do students learn best? So they had three groups, one that did hands-on investigations only, one that learned from text, and a group that did both. So the classrooms who used both hands-on investigation and text significantly outperformed those who did just straight activity-based hands-on or text only, okay? So that leads us to some ways of looking at our instruction of, explain and then explore. So sometimes we would introduce the concept or the term to our students, and then we would give the investigation for them to do. But the research in science education is looking at flipping that, where students do explore first before explain, and what that does is help students to build context. Children come with an understanding of how the world works. They may lack the formal terms. So for example, a child's going to know if I throw the ball up, it's going to come back down. They may not know the term gravity, but they have that ability to sort of bring some of their ideas and then be introduced to that formal terminology. Okay, so now we're going to talk about unpacking the scientific methods a little bit and getting into that. Okay, so when we think scientific method, many of us sort of have sort of the high school background, or maybe if you're lucky, you did some in university, where there's that sort of linear approach of observe, question, hypothesis, planning materials, and that is a definite investigation. But controlled experiments are focused on in 5 and 6, and that's to do with manipulated and independent variables and hypothesis. So we're going to look at investigation as a whole. So science disciplines have different types of investigations. So for example, we've got, Jane Goodall observing her gorillas or chimps in the forest. She can't control her environment. So she does descriptive investigations. Or there's comparative investigations where we're looking at systems over long-term or periods of time, weather systems and climate and things like that. And then we have experimental investigations, which is something I think we're all familiar with from high school, where we're testing that one thing. So for example, like in the picture, what's going to keep from spoiling the meat from spoiling and the maggots away? Well, let's just look at the seal. So they just only change the seal and everything else stays the same. So there isn't a hierarchy. There isn't any sort of, one is better than another. They're just suit different purposes. And in grade 5 and 6, they're really going to start focusing on experimental investigations. So think of investigations as an umbrella, and that the other types are underneath. So there is a purpose. There should be some kind of question. They're observing a phenomenon. How does this work? Why is this happening? Some kind of, it doesn't require a complete scientific method. And a hypothesis is not always necessary. In an experimental investigation, there is also a purpose and a question that's posed, but it involves testing those dependent and independent variables to confirm or refute a hypothesis. And it follows that classic scientific method. Okay, so in primary, you're not so concerned about that, and we'll touch on that a little bit later as well. So I'm often asked the question, how do I teach this? Do I introduce it? Many of you probably seen some of the scope and sequences from Edmonton Public or other divisions. And yes, you can introduce it, but the expectation is that, and I pulled this out of the subject area introduction, that students will be integrating it through other organizing ideas. So it's a way of building knowledge, as we learned in scientific literacy. So we have to provide our students with that opportunity. Okay, so we're going to look at unpacking the scientific methods and at each grade level. And we'll do a little bit of processing work here. So I know that Ted has probably talked about the architecture, so I'm not going to get into that too much, but I'm just going to look at scientific method and the organizing idea. So when the curriculum was developed, the organizing idea is, if you want to think of it, is grade 12 with the end in mind. So if investigation of the physical world is enhanced through the use of scientific methods that attempt to remove human biases and increase objectivity. So with the end in mind, they're looking at grade levels about how do we get them there? How do we get them to understand that? So then we have the learning outcomes and the focus in each grade level, okay? And that's what we're going to zero in on in grade 1 to 3 today. And we're going to unpack some of that because they build on each other. So the question for assessment is, again, I just want to stress, is the learning outcome is what you will be summatively assessing out on and reporting out on. So that's a combination of what students know, understand, and can do. The cusps are like the ongoing learning outcome broken down. So you are expected to teach all of the cusps. You should formatively assess most of the cusps, but not all. Okay, and I will highlight a few areas where I would be like, this might be one where I teach it, but I might not do some kind of assessment on it. And it's an opportunity to provide feedback to students so that they can improve and grow. Okay. Quiet in the house. Hey, Ted, no one's asking questions? All right. So I want you to think of the scientific method as an ongoing process. And there's going in each grade level, we're going to be looking at it from a cyclical perspective and unpacking it at deeper layers, or like nesting Russian dolls that each one kind of builds on each other. Okay, so we're going to do some processing work today in a program called Lumio, and it's pretty straightforward. So what's going to happen is, in a moment, I'm going to drop a link in the chat. And when you get it, you're going to see a screen like this, where it has my name and a class ID. And then you just type your name and join as a guest. I'm going to lead the slides for the next 10 to 15 minutes. I couldn't put my whole presentation in Lumio, unfortunately, so I had to kind of pause and do it this way. So again, you're going to see a screen like this, and you just type your name in and join as a guest. And then we're going to work through it just like we would with Pear Deck or Nearpod, okay? So also what'll happen is it'll be like I'm controlling the presentation, but it says a handout. When you click start, that's when you can interact with the screen, okay? Any questions before I drop this in the chat? Everyone clear? Ted, do you have any questions?
No, I don't. I've never done this before, so it may be new for everyone as well. So we'll just go ahead. We'll see what happens when we get the link and put our names in, I guess.
Yeah, so what'll happen is a new screen will pop up. So we'll still have Zoom in the background.
Right.
But yeah, it'll just
Well, we'll get it going here, and we'll see. We'll go to the login screen when you post it, and we'll take it from there.
All right, so I'm dropping the screen in the chat, and I'm just going to wait. It tells me, when you log in, your name as soon as you put your name in. Oh, Danielle's already in. Great. Oh, everybody's getting in. This is awesome. I'm glad it's easy.
Laurel doesn't know how to do this at all.
Okay, if you are in, sometimes if you're on your phone, it might not be so easy. So if you're stuck, just watch. I'm going to keep everything up on the screen and you can follow along with us. Okay.
Yeah, my screen says like join with QR code, students go to Hello Smart, blah, blah, blah. And then there's copy, link copied, and then got it.
Okay, and then
I can't type my name in that anywhere, like I can
hit
see.
the link, and then it should, if you get into
Hit
the
what
link,
link?
it should, or the class
Oh.
ID.
The
Yeah,
link in the chat box.
The link in the chat box.
Yeah,
Okay,
just open up your chat.
there's two of them there now, okay?
yeah, they're the
either one.
same.
Okay.
Yeah.
I've
Okay,
never
we're just
used
gonna wait a
that
few
before either.
minutes so
Okay.
everybody can get in. Okay, so we're just in Lumio, got a few people still kind of joining, so I'm just gonna go ahead. And you should now see the screen that says Science Investigative Cycle, grades 2 to 5. Okay, and if not, then just in your following, you can still follow along here. All right, so what I've done is in grade 1 has a smaller version of this, and we will look at grade 1, but I wanted to use this because this is pretty standard for what every grade is going to be using for an investigation cycle. So it's laid out in grade 2 in the knowledge statement that this is the procedures of an investigation: asking questions, making predictions, planning the investigation, observing and recording data, analyzing data, reaching conclusions, discussing observations and conclusions. So you can see that I've put it as a cycle because that's what it is. They're really, you could be asking questions at any point during an investigation. It always isn't just starting with asking questions. Okay. But we're going to kind of go with that and look at some of the skills and procedures from the scientific methods and see where it aligns. Okay. So what we're going to begin with is, now I've moved on the screen to grade 1, and we're going to look at the outcome, which says students engage in and describe investigations. So what I've done here is I've circled the verbs and put a box around the concept of an investigation. So students are going to engage in, that means they're doing it, but they're also being expected to describe it. Okay. So I know I have a little bit of arrows here, but just I've color coded them. So in black, it says ask a question sparked by curiosity. So the knowledge statement sort of sets those parameters for you. An investigation is sparked by curiosity. That's pretty straightforward. But if we look at predict, which is circled in red, and you look at skills and procedures, predict the answer to a question. Well, I love that it has been defined here as a prediction as a likely answer to a question based on a current understanding. Because in the, before I would go into classrooms as a consultant, or even probably when I started, a prediction is a smart guess. But as a student, what does a smart guess mean? So I really like how it's laid out for us that, and our students need to know this, that it's, it's likely, it's connected to what they're looking at, but it's also based on their current understanding. So there's some reasoning involved there. And if you look at the square underneath, describe the steps of an investigation. Well, it outlines it for you and for the students what they need to know. In grade 1, particularly, asking a question, making a prediction, gathering data, and forming conclusions. So it's a little bit of a smaller scale than the one that I showed you for grade 2 and above. Okay. And yes, Catherine, I agree. It's better than a guess. All right. So now we're going to go on the second set of cusps for grade 1, which is the understanding is recording data helps ensure observations can be referenced in the future. So again, what I've done is match the skills and procedures with the knowledge. So in order for students to make observations using their senses, they need to know that observations can be made using senses. And that's a great way to start in grade 1 for scientific methods, by the way, because in kindergarten, they're going to be learning about senses, but this group probably not. So that would be a nice little bridge to begin with. Record observations as data. So then it gives you the parameters. What do they need to know in grade 1, or even the grade 1 students? Well, observations can be recorded as data in many ways, such as, and then they list it. The such as we know means you want to give them a sampling, but you don't have to do it all. So of course, words and drawings and photographs they're familiar with, but we can do video recordings of their investigations, or numbers and counts, so bringing in that math. And then they need to reflect on recorded data to make conclusions. And I love this because sometimes we would just get our students to just make observations and record them, but actually getting them to look it over in order to answer the question. So that's really important as well. Okay, so now is the little handout. And basically what you do is I have a list in green of all the skills and procedures for the science methods in grade 1. And so then what I'd like you to do is look at the skills and procedures and match it with the investigation cycle. Now this is grade 1, so and I just used the other ones. So planning the investigation isn't part of it, but see where would you put it. So if you could go ahead and drag where you think it is, this shouldn't take too long. Catherine, you said what grade did they get the definition of data? I think it's grade 2, but I think we'll have to kind of, you know, talk about that a little bit more. All right. So if you want to take the green and just basically match it to what skill and procedure you think it is. Okay, so I'm like looking in here. So you can ask a question sparked by curiosity. Well, what part of the process is that? So you should be able to drag it good. I see some people dragging it to asking questions. Great. That's what you should be doing. Awesome. Because we're going to continue with this in the next, with grade 2, we're going to see how this relates. So I just want to give you some time to kind of process this and see where it goes on the steps. And I'll give you guys about another minute or so, because I know this is not as long or as much. Okay. I know grade 1 isn't as much, so I am going to move on to the next screen. So it is going to stop you. Okay. Okay, so if you see on the next screen, it says grade 1, and I've just narrowed it down here. So I took out everything else. If you put, obviously predict and answer goes with making predictions, right? But making observations, recording observations goes under gathering data. Reflect on data to make conclusions is forming conclusions, okay? And they're describing the steps. Now is where we're going to add layers to that nesting doll or that unpacking like the onion piece. We're going to look at grade 2 and think about grade 2. Good so far? Any questions? Okay. All right, so in grade 2, if we look at the outcome for grade 2 is students examine investigation and explain how it's influenced by purpose. So again, I've circled the verbs or what students do, and what they're understanding is investigation and purpose. So that's really big in grade 2 because I've been working on a unit plan for matter and scientific methods, and purpose comes out quite a bit. So students are examining in the investigation now. So the grade 1 laid that foundation. What is an investigation, right? You know, we've got prediction and observations and recording them and using those observations to make conclusions. Now we're going to look at, okay, let's look at this a little deeper. And how is it influenced by purpose? Okay, so we're going to go into the cusps, which will help lay this out a little bit more. Okay, so we have 2 big areas here on the knowledge side that kind of spread out into the skills. And that is that explore various purposes for conducting investigation and develop questions for the purpose of investigation. So what are the purposes in conducting an investigation? That's laid out in your knowledge area. And it's answering questions, you know, there's different reasons for that: building knowledge, satisfying curiosity, and problem solving. And that's really foundation. They need to know, why are they investigating and what's the reason? What are they trying to find out? Now, the procedures of the investigation is the cycle that I had shared with you at the beginning for grade 2 to 5. This is where it's laid out, okay? And it's sort of implied. It doesn't say that it goes through grades 2 to 5. So that's why I really wanted to pull that out, that these are the procedures that in grade 2 they're expected to describe. You know, asking questions, making predictions, planning, and so on, okay? Okay, so now let's look at the second set of data of cusps. Sorry, I've got data in my head because someone asked that question. So we have determined if observations relate to the purpose of an investigation. Well, that if they're going to be observing data, it has to sort of connect back to purpose, just as what are we trying to find out here? And then if we look at the second skill and procedure, collaborate to combine recorded data into a single list or chart. Okay, so they need to know that that's what we do, and then compare their observations. So observations should be similar. Okay, if their investigation is repeated, and the repetition includes performing the procedures in the same way. So you have different groups, or students could be working in partners, they're going through the process, and they should be getting the same results. And if not, that should be a question that's being asked. Okay, so what we're going to do now is, again, you're going to see the cycle process. And what you're going to see now is I have the answers for grade 1 up and laid out. Okay, so you'll see the yellow kind of or green laid out. And what we'll have is blue is the skills and procedures for grade 2. And those skills and procedures, so you might want to look at, well, what gets replaced in grade 1, or what do we keep in grade 1? What comes forward? What are they still expected to do in grade 2? And then from grade 1, and then what can we add to or unpack the deeper layer of in grade 2? Okay, so if you want to hit this, I'd like you to take a few minutes to now do the handout sheet. So you're going to drag forward what's in blue. I've already kind of laid out what's in green, sort of the answers before, and you might be replacing some of this because we're going a little deeper in grade 2 now. So I'll give you guys a couple minutes to kind of work on that on your own. Already see observing and recording data. Someone just put in collaborate and combine record data into a single list or chart. Awesome. I'm helping everybody out with that one. So I'm going to give you guys a few minutes with this one because it takes a little bit longer now. It's a little like grade 1 was a little bit easier, but grade 2 we're adding that layer.
While we're doing this, can I bring up a couple of questions that were in the chat?
Sure.
I think you alluded to the question about data, the definition of data. I'm not too sure if you have anything, but I can't really find a definition. I do see examples of data, but there's no specific definition. Is that your understanding?
Yeah, I do have, in my handout at the end of this session, I do have it defined as like measurements, facts and measurements. So based on observations, that's basically the definition. It's not in the curriculum, but that is what data is. And that's a great question. Thank you for asking it.
And another question is, reads this way: as a STEM school, my grade 1s learn the whole sequence in depth. This is okay, right?
Teresa, I'm not sure what you mean by the whole sequence. Do you mean the procedure right away, or I'm thinking grade level, but you're talking like you introduce asking questions, making predictions, that kind of thing for grade 1? Oh, that's okay to introduce at first. Yeah, and I do have a video. I think we're going to have time today to actually go through it. That talks about ways that you can introduce the science methods to your student. That is one way you can definitely do that. And then, you know, go back and they have to kind of figure it out. Okay, so it looks like, thank you, Teresa, for asking that. And I'll make sure to hit on that as well. So it looks like most of us are ready to kind of move forward. So I'm just going to give you guys like about 30 seconds to finish up if you haven't already placed the grade 2 skills and procedures. And then we'll take a look at it. All right. Okay, so we're going to move on. Okay, so in the science investigative cycle, so the green is stayed forward. You may see that I've replaced it, and then I've started determine if the observations relate to the purpose of the investigation twice. And the reason for that is because they're thinking about purpose, and when they're planning an investigation, and they should be starting to plan in grade 2 with guidance, obviously, is that's what a prediction kind of is. So they should be anticipating, what am I going to observe? And does it connect to the purpose or helping me find the answer to the question? But also when they collect it and they start analyzing, they collect it, and grade 3 goes into analysis more. But when they start collecting and recording it, they should look back and go, does it, help me find the purpose of or answer for the purpose of the investigation? Okay. And they should reflect on that data and continue to do that and continue to make those predictions. That is still, even though that's something that grade 1s have laid out foundationally, have taught and assessed, that's still something to be carried through. And that's a great idea to start with in grade 2, if they, is to refresh them with, if you're introducing the scientific methods on making a prediction. And Ted made a really great concept attainment, which we'll go over later. Any questions about grade 2 before moving forward? Anything that you're just wondering or anything like that? Okay, we will lastly look at grade 3. So we will come back to something like this with the grade 2 kind of out, and then you're going to see, well, where does grade 3 layer into this investigation cycle? All right. So grade 3 is looking at students relate investigation to building knowledge. So if you think about when we talked way back about scientific literacy, and that is a way that, that investigations or procedural knowledge, that's how knowledge is built in science. That's what scientists use. They aren't given videos or things to read. I mean, of course, we want to help our students, but we need to kind of start thinking about getting our students to build knowledge through an investigation. Okay, so they relate that. And if we look at the cusp, there's only one. So we have lots of circles here. If this was in PowerPoint, it would have been one at a time. But anyways, so look at the light blue first, collect data using techniques to improve the accuracy of data. Well, that's a lot to unpack here. So they've done that under the knowledge statements, right? So we'll start at the top of knowledge that techniques can be used to improve the accuracy of data include. So include means grade 3, you need to do, this is what we have to do. So choosing appropriate tools. Okay, so when they're going out, they have to choose, okay, should I use a ruler or a meter stick? Which is more appropriate? Or a clear plastic container versus a blocked glass. It doesn't always have to do with measurements. If I need to observe something, would a tool be like using a clear plastic container so I can see through it? Carefully measuring, of course, measurement starts to come in here, and demonstrating objectivity. Well, we have to go down, third knowledge statement. What is objectivity? So that's defined for us. So objectivity is an attempt to remove influence personal thoughts, feelings, and expectations. Again, I'm going to talk about what this looks like in the classroom, and give examples of that a little bit later. We're just unpacking this here. So accuracy, well, that means the correctness of recorded observations. So that's something we're going to really teach and assess and focus in on in grade 3. And unfortunately, this didn't translate very well, but the red should correspond with the red. Analyze data collected during an investigation. So here in the red box, it is outlined. It says they make connections to their previous knowledge when they're analyzing data because they're making an inference. And we're going to get into the distinguishing between an observation and an inference. comparing for accuracy. So again, in grade 2, they were learning to compare and look at similarities. They're going to compare and look at, how accurate is our data. Noticing changes is something I think you would highlight, especially if they're looking at graphs or tables. What are the changes? What things are repeating? Because actually patterns kind of do indicate something when you're analyzing, but even what's changed. So that's there. And discussing and collaborating. Scientists will actually, they may refer to another scientist and say, well, what do you see in this data that I'm not seeing? Okay, and then compare the trustworthiness of sources of data. So data can come from, if we look at the knowledge statement, investigate such as. So again, such as means you don't have to do all of it, but you want to expose students to a variety of it, like investigations, text, websites, of course, elders and knowledge keepers, with the inclusion of First Nations, Métis, and Inuit perspectives, community members, and personal observations. Okay, so they need to be reading too, and we need to be kind of talking about those things and teaching those things as well. And then develop further questions. So again, remember it's a cycle. So again, they're going to be asking new questions once they analyze the data. And they're going to reflect the very top. They're going to look back on conducting an investigation and how it contributed to their building of their knowledge. Okay. So we're going to look at and do the final interaction with the skills and procedures from grade 3 and see where does it go on our cycle and what still is being carried forward, some from grade 1 and grade 2, and then what gets added on or replaced with grade 3s. So I'm going to give you a few moments to go through that, and you can hit and work on that. So what's in red is the skills and procedures that you'll drag forward. I've kind of laid out the answers previously. So then, and if it's on the side, it's for the whole thing, but you can work now with grade 3 in red. Okay, this one, most of you have been kind of pretty fast with. I'm just walking through and checking out. So I'm going to move on to the next screen and just sum up. Okay, so reflecting on data building knowledge and contributes to knowledge building, that's kind of looking back at the whole thing. So once the whole thing is done, that's when the students will do it. But yes, develop new questions for further investigation. Grade 2, they should be thinking about the purpose of investigation in grade 3 as well. What are we trying to find out? Because sometimes we assume that students know, and not all students do. So that's great. Making predictions, keep doing that. That comes forward from grade 1. And determine if the observations or relate to the purpose. They should still be doing that. They should be still thinking about their predictions and what am I going to observe? Is that going to help me answer the question, right? And they're making observations, recording that all the way from grade 1. And now they're collecting, now we're going to add to that layer, right? Of unpacking that, collecting data to improve accuracy. And then, of course, grade 3 really focuses on analyzing data. So I kind of put that there as a replacement. But again, the reflecting on data to build knowledge building, contributes to knowledge building would be happening after they've gone through an investigation and they've reached their conclusions. So they can kind of go, oh, how did my thinking change? I used to think this was going to happen, but this happened, right? Okay. So this concludes on not the presentation, just our work in Lumio. So I'm going to exit out. So what'll happen is it is on a different tab for you. come back to the Zoom meeting and we're going to be back into the PowerPoint presentation. Okay. Let's come back and I will put up the PowerPoint presentation. I'm not sure how I got these yellow on my screen, but okay. So most of you, I hope, are back into the Zoom. And here we are at the end of the unpacking and processing. So I hope what you've learned from doing that and looking at each grade level is seeing that it builds and it goes into a deeper focus. So there is still an expectation from grade 1, which is a foundation of what is an investigation, making predictions, making and recording observations, and making conclusions, which is an answer to a question. Grade 2 then goes in and adds to that with looking at purpose. So developing questions for the purpose of an investigation. So you're still making predictions and recording, and then through planning, determine if the observations will relate to the question. And of course, recording them, you're still recording that observations and collaborating to put on a single chart so that, okay, what we're doing should repeat. If it's, we're getting those facts, those data, those answers, it should repeat. Everybody should be sort of getting the same results. Grade 3 continues with some of that, pulling it forward, but then looking deeper into collecting data with accuracy. And when we look at classroom examples of what that would look like, we'll kind of talk about that. And then really going in depth in grade 3 in analysis, because in grade 4, they're going to look at interpreting. And interpreting is pulling the meaning from the analysis. So your foundation in grade 3 is going to set them up for grade 4. And of course, looking now at the trustworthiness of data and reflecting back on that and saying, okay, we did this and I was building knowledge. Okay. All right. So now we're going to look at the third part of this presentation. Is what does this look like in the classroom? What are some common skills? And, this might be an area of review in, I'm just going to, I don't know how these yellow marks got in here, but I'm going to try and get rid of them because they're bothering me. Sorry about that. I don't know where they came from, but okay, I can't get rid of them. Sorry about that. Yes, and I will be sharing a handout at the end with the connection to the slides and lots of goodies there. I even developed sample lesson plans for you that you can start off with, and then grade 1 goes in a certain area, and grade 2 and 3, and we'll talk about that. Okay. Yeah, I think someone annotated, so please, it's okay. Just don't worry about it. All right. Yes, of course, I have your back. So I want you guys to have some handouts and things that you can use as well. Okay, so we're going to look at making predictions. We're going to look at some of those common skills that are carried forward from year to year. Making predictions, making and recording observations, and making in conclusions. So a lot of this, because this is going to be new and bridging, and even like math and other subject areas, they go on to the next grade and they say, oh, we didn't learn this. Well, yes, you did. So review is always good to do in September, and these might be some great review points to begin with. So before we begin, though, I want to mention, some people ask me, do you prefer science? What do you think about science journals? I love science journals. And if you're comfortable, go for it. If not, you can use graphic organizers or have them glue in graphic organizers. If you use a journal, table of contents always helps to keep them organized. But the one thing I do want to stress is having a glossary or a science word wall, because the terms are different. And even with what they're learning and other organizing ideas, I really think what's good we have a high percentage of ELL learners, and what's good for ELL is good for all learners. So, whatever works, you could have them have individual glossaries or have a science word wall with terms and definitions. Okay. So on that note, when we talk about graphic organizers, I have seen things floating around for our curriculum, and I saw things like the scientific method. And now, when I say not part of our curriculum, I'm referring to primary, because hypothesis is grade 6. And we don't want to confuse our students. They should only be making predictions in primary and up to, grade 5 inclusive. So some of those things that are out there on Teachers Pay Teachers are fine if you ensure or adapt or change them to align with our curriculum. So in the goodies that I'm giving out today, I made an example template that you can grab, use part of it. You don't have to use the whole entire thing, or you can if you want. But so for example, this is great. Every grade level has a different one that's sort of focused on what the grade is. So for example, grade 2 says purpose, right? And then prediction. So again, it's going back to that procedure that we just went through for the science process. And thinking about your grade level and what the focus is. All right. Okay, so as we look at samples in the classroom, I want you to think about assessment, because you are expected to teach and assess the learning outcome and the cusps along the way formatively. So when we think of assessment, I want to remind you about triangulation of evidence. And I know we think of testing, right? Or demonstrations and projects. And I think primary is very, very good at this, of doing observations. So if you want to think of it, you are scientists of your students' learning. You're gathering evidence of their learning. So think about, just a reminder to think about triangulation of assessment. So observing the students. So you may need your own checklist, or anecdotal records, or you might video them. Students having conversations is really important. They should be talking in all subject areas, not just science, to make a meaning, to try and build understanding. So, what do you want to hear from students? So when you're observing, what do you want to see from students? What do you want to hear from students say? The product is, or could be projects, presentations, okay? All right. Okay, so now we're going to look at making predictions. We're going to talk about teaching and assessing that in grade 1 and how it continues to be implemented in other grades, so we're all aware of what a good prediction is, and introducing it to our students, and then teaching and assessing it. Okay, so from our curriculum, a prediction is a likely answer to a question using what you know, okay? Or your current understanding if you think about what it says in grade 1. So Ted created this. I love it. And it is attached. I know he probably has it in his handout as well. And a concept attainment. And Ted, I'm going to share how to do it, but if you want to step in, and by all means, please do so, because this is your baby. But I showed one for grade 1, and then we made an adaptation for grades 2 and 3, because they're a little bit older and could probably do a little bit more. Okay. All right. So look at the images. You're going to see images, or the students are going to see images, and look at the images that are the yes and the no statements, and think about, what do all the yes statements have in common? Okay. So this is just an example. I'm not walking through an entire one. We're just going to highlight a few things. And the first one is grade 1. So this might be something you could do. Of course, predictions are going to be all year, but you could be introducing it through this way. And I think this is a really nice way of getting them to think, is the runner is going to win the race. And the no statement is the runner is at the start line. Okay, so grade 1 would probably have a series of things like this, right, Ted? Or is there anything you want to add to that?
No, that's right. You give them different situations, and at the beginning you give a yes and a no. It would be more helpful if they were able to see all the example and non-example statements in a line. So if these could be made as pictures and put on a wall or something, would be helpful, so that it's easier for students to look at all the yeses and all the nos together. That's the only thing I really have to add.
Yeah, and that's a great point. So there would be a series. This is snippet that we're looking at, because this is grade 2 and 3, and then I had, well, this could be grade 2 and 3. An example at the beginning of the year, the snowman will melt in the spring, because the spring it gets warm and snow melts, right? That being able to, give that reason behind it. Grade 1, they're just starting. Okay, so those samples would be more simpler and more of a series of them. And I think what Ted is saying is absolutely correct. They should see a series of them, because just seeing one isn't going to tell them. So in your sample lesson handouts today, you'll have those, and they have a series of them. And the no statement is the snowman will walk away because I watched a cartoon and the snowman walked, right? That's kind of not likely and not relevant to what's really happens in the real world. That's an example. Or this one, this is another grade 2 and 3 example. The girl in the white shirt and red pants will catch the ball because it looks like the ball is falling towards her. No statement, the girl in the light blue shirt will catch the ball because I want her to. Okay, so then after they go through a series, so we're just doing the snippet again. So as Ted said, you would show a series of slides with pictures or have them posted in your room and have them look at it. All of the yes statements are predictions. So get them to come up with, what is a prediction? Okay, so that explore before explain kind of thing. Then I would have also introduce, so to fill in the gaps, because sometimes not all students are going to get it, but it is really good to get them thinking and their brains are primed, is introduce for your word wall or for their glossary, predict a likely answer to a question using what I already know about a topic. Okay, so I want you to think for a moment. So in grade 1, they're assessing. So this is going to help you think about assessing these skills and procedures with the scientific method in any other skill. But let's think about this. Based on what you've learned about predictions and the criteria, so from our curriculum, and I put the knowledge statement with the skill and procedure, what would you expect to see or hear from students for a grade level expectation for our curriculum? So if you want to drop that, and now grade 1, that would be probably more towards the end of the year. But if you want to drop that in the chat, what would you expect to see or hear from students when they're making a prediction, a solid prediction? Yes, things will be translated in French and be sent forward. So if you just want to take a minute, and again, remembering our agreement, there's no right or wrong, like you're just learning together, just thinking about what would I expect to see or hear from students when they make a solid prediction? Awesome, thank you so much. I think because, okay. All right. Thank you so much for taking a risk. Thank you, appreciate it. Giving a reason, okay. Using prior knowledge. Okay, so we'll look at an example.
One of the questions that flipped by was the distinction between a hypothesis and a prediction.
Okay, a great question. A hypothesis is so a prediction is what you you think will happen, or and then there's obviously a reason behind it. And a hypothesis in our curriculum is like a scientific explanation of what is going to be happening. So for example, in grade 5, so grade 6, they're going to be focusing on testing their controlled and independent, like their manipulated and their variables. So it would be sort of like, if I change the lid on this on this container, the maggots will, and the responding variable. So it's kind of like what they anticipate is going to happen. It's based sort of like an explanation of what they think is going to happen. Okay, so a prediction is sort of more broader. There is an element of predicting in a hypothesis, but it's a little bit more structured. And I hope that makes sense. I hope that kind of worked with that. Does that, or do you want to add to that, Ted? Is there anything you want to add?
No, I think for me that covered it anyways, unless I forgot who asked that question. That person may still need some clarification. I'm not too sure.
Yes, in 1 to 3, actually in 1 to 5, we should be predicting. Yeah. That's great. And I'm glad that we're getting that because that's, yeah, in our curriculum. So if we look here, this is a grade 1 example. So I had like, of course they can draw and they can, things that grow outside. So for example, here, the teacher is thinking, okay, I'm going to and a lot of you touched on this, a likely answer based on what they already know or reason or prior knowledge. So for example, the question is, what do you predict you will observe grows outside? So the student response can be verbal or pictorial or written, as they get older in grade 3. But if the student response is, I predict I will see, or, let's try and get them to use the word observe, grass, birds, and trees, because when I go outside, I see grass in the field and trees get bigger and the grass grows, you need to cut it. So what you might likely get is a partial prediction from students, especially in grade 1. And of course, that's going to happen. I predict I will see grass, birds, and trees. And if they stop there, you can always use the prompt, what makes you think that? Asking why, sometimes kids will be like, I don't know, or they get kind of freaked out. But using the prompt, what makes you think that? Usually it opens it up for them. And I have this template as well. If you wish to use or not use, that's fine too. So I've made a rubrics as well, and I worked with our assessment consultant to come up with these rubrics because we are assessing. So the criteria is broken into 2 categories. Student provides an answer to the question that is appropriate to the context, right? The likely answer. And the second part is student shares the reason for the answer based on what they already know. And if you're struggling, there's some prompts here. So how to help students if they're working through some of these predictions. You can also turn this rubric into a Google form. I did that and I was like, oh, I'm going to share this out, but it wasn't sharing properly. So I'm just sharing that out, that you can do that. So with teaching this through the year and you introduce it at the beginning of the year, I do gradual release of responsibility. And I think that works really well. And I don't do I do as in I write the prediction. It's I think, because again, the science methods are a thinking process, right? So you can model a think aloud for your students. Well, I think when we go outside, I might see some birds, and because I've seen birds before, and then we think together. So that interactive piece. So you might start, okay, I think we might see birds and trees. What else do you guys think? And then why? What makes you think that? What's your reason? And then they can do a think, pair, share on the carpet and share out with you. Or they go off and they predict what, then eventually they're going to get to the point of doing it with their partners. Towards in grade 1, maybe the end of the year. So in grade 2 and 3, this might be a little bit quicker. And it's not so linear. Sometimes we know our students struggle with certain aspects or elements, and you need to go back. Oh, I think we need to do this together. I need to reteach this, right? So the gradual release of responsibility is obviously a nice thing for skills as well. Okay, so we're going to spend a little bit of time in making and recording observations, because that carries through in all grade levels, and how to teach and assess in grades 1 to 3, and what are some foundations and expectations, as well as in some of the research and literature on science education. What are some challenges for students and misconceptions, and what can we do to kind of work around that? And I alluded a little bit earlier about observation and inference. Okay, so there are sort of criteria for making or characteristics for accurate, like in grade 3, it says accurately recording observations. However, we can always guide and help in grades 1 and 2 as well. So there are some competencies with recording observations. So I'm going to highlight these. Is it should be clear when recorded, and we learned this in grade 1, scientists go back and use it as evidence, right? They're going to look over their data or their observations and make conclusions. So it should be clear that they can do that and be able to read their notes or their pictures or words. It should be complete and have all necessary details to describe the situation, event, or object well, and accurate. So here I'm going to touch on how it's more than just measurement. They need to represent what is actually seen, heard, smelled, or touched as closely as possible. Now, this isn't an art class, but it should be recognizable if you want to think of it that way. That it's not just sort of a scribble. And in grade 1, they're learning, so that's a little bit different, and they're working towards that, right? Now, of course, in grade 3, if they're or in any other grade, if they're using measurements, they're accurately recorded with their units. It should be objective. So again, that was highlighted in grade 2. and 3. And so, for example, I'm going to use, okay, yes, using a standard tool, they're measuring exactly, but not describing emotion or feeling. So, for example, they might say the seed is small. That's actually where children tend to jump into making inferences. What they should be doing when they're recording an observation is using, the seed was 35 millimeters, not saying generalizations or inferences that the seed is small, but seed is 35 millimeters. Or the seed is 3 paper clips long, if they're using non-standard in grade 1 and 2. And then it should be labeled, and when appropriate, use scientific vocabulary to go back. So again, reinforcing that learning of the vocabulary and whatnot. Okay, so as I mentioned, there are some challenges and misconceptions when recording observations, and this came out of the literature, and some of it's going to be common sense, but some of it's kind of interesting. So students think they will remember their observations, so they don't write them down or label their observations, kind of like their homework. Students often record inferences rather than observations, and that's just human nature. We jump to a judgment. So for example, instead of writing the grass is brown, they'll write the grass died. Okay, and we'll talk about how to work with that with students. And students might not notice important details, or sometimes they like to attach emotion to their observations. Okay, so how do we work with overcoming these challenges with students? So if we know what a good criteria is, co-construct it with your students. That means if your students are part of the process and they know what it is that's expected of them, if they know the target, they're better able to hit it if they know what to aim for, okay? So you could develop and co-construct criteria and then use student-friendly language to kind of work with it. And if students know that, then they can give feedback, and that pays off in gold. I used to have that and teach my students how to, and I've taught grade 3 and I've taught grade 2. It takes a little bit of time, but it's well worth the time invested that they know how to go back. Like before they say I'm done, okay, we'll go use the checklist and have you, is it clear? Is it recognizable? Those kinds of things, right? And this is an example of a teacher assessing, sort of an observation here. Use of sentence stems to support all learners. So again, I mentioned that Alberta has a high percentage of ELL learners, and what's good for ELL is good for all learners. So these are examples. I would just choose one. I just gave examples here, like I notice, I observe, I see. The blank measures blank. This is different from earlier observations because, and then you can have a word bank for students to choose from. And that's one other thing you can do, and examples and non-examples. So once you've co-constructed criteria and you're teaching them how to look at that criteria, use the examples. So I have one on the top here. I just have 2 here, but you would show your students one at a time an example and a non-example. So you can see it's not recognizable. And then that way it's very clear for students. Oh, that's what that means. So for grade 3, I took a picture of a boy recording the observations. And the boys are being accurate in the other picture, but they're not recording. Okay, so these are some great things that you can do to overcome some of those challenges. Now, the distinguishing between an observation and inference, and the children will jump to the grass died instead of describing it, which is kind of why I like to start with matter, because the world we live in, everything is matter. Landforms, mountains, people, cats, dogs are matter, take up space and have mass. So it really gives them the vocabulary to be able to make observations, to describe the shape, the color, that type of thing. So at the beginning of the year, especially in grade 2 and 3, or even further, or younger too, you could do sort of a game, like an I Spy game. So for example, they might see, I see something round with a black circle with a little white circle in the middle with kind of little eyelashes. Okay, so that, what, and then the class would guess, I think it's the eyeball, right? So it can turn into a guessing game. And, you could start off with, and I have slides for this as well, so that they could do that as a whole class, then maybe, go off in partners or whatnot. And this is connected to the lesson that I'm going to be sharing out that you can use at the beginning of the year. Also, when they're not noticing a lot of details. So I use a ×2. These are all thinking routines, looking routines. So that could be where the students look at an object or an image and describe it, and then look away, look back, and you sort of say to the grade 1s or older, oh, you're casting a wide net with your eyes. Look back and add something else that they didn't see in order to do that. Okay, so this is a nice way to really help working on those observational skills and distinguishing between making an observation and an inference, which an inference is a conclusion, really. So we're getting to that point, making conclusions. So we'll define that. We'll look at how you can work with it whole class or review at the beginning of the year, and then different ways to represent your thinking. Okay. So a conclusion is a statement, a claim. A claim is an answer to a question, and it draws support from data. So again, data being measurements, facts, figures, those type of things. So what you could do for whole class, and I have worked with grade 1 teacher who on the left here with living systems. This is a thinking routine called claim support question. And if you don't have anchor charts, you can also use slides too. But she brought her dog in, and the students had to say whether he was living or non-living. So for example, is Boogie living or non-living? Boogie is living because he's breathing or he needs air. So the support is, well, what did you observe, right? So I know he's breathing because his chest is moving up and down, or he's panting. I can hear him. So the teacher recorded that. And the thinking routines always have questions, which are really good. That gives you insight, because students will ask questions about things they don't know more often than things they know. So then it might be things that you're like, oh, I thought they knew this, right? So it's always good to ask that. Grade 2, this is an example they did with light energy. Another learning summary tables, and I'm going to be using those in my units a lot that I'm going to be sharing out in my sessions in September, is one of these, and I've used this a lot in my own classroom, is called clues. So clues is every time, so you can see here, this one is with light. So every time they do an investigation of certain things, they'll have a question, a hands-on investigation. What do you know about it? What's your prior knowledge? Accessing that. Then what did we learn? And then what is that evidence? Evidence is used in grade 4 to 6, but you can say, support from data. So what did we see or, hear, or any of those senses? And then what questions they have. Now, I liked the S at the end because it connects the scientific concept of words that are related. So that vocabulary piece, being a science consultant, especially with grade 6 and PATs, and this builds every year, it's the terminology is what's challenging for students, the vocabulary. So I have here an explanation of clues at the bottom of the screen. And yes, these all will be shared out with you today. I have a little handout for you. Okay, so students, of course, can write, but we can also, and it doesn't matter if you think of differentiation or inclusion, having students have a picture and they label and use symbols is really probably shows the flow of things or how things work. So this is the playground slide bump. This was kindergarten, but I think this would be a grade 1 activity. So you can see that the teacher provided some of the vocabulary and words, and some of the kids put them in. Where did the puddle go and why? That is actually connected to the water cycle. So they have the flow here and they draw, and then they write about it. So those are different ways of representing. Grades 2 and 3, this is an example where the students, this is phenomena-based learning. So at the beginning of the unit, they were observing a man singing and he broke the glass. So all through the whole entire unit, they kept doing little investigations and kind of trying to explain why. And at the very end, this is their explanation. This is their conclusion. And you can see symbols are added and words, and, they're writing or talking about it. So if you want to reach all learners or think of multimodal representation, they can draw and describe orally, they can write paragraphs, you can record using, different forms of technology to help with that. Okay. So again, the gradual release of responsibility is very helpful because these are year-long processes, especially in grade 1, and even with the other examples or what you will be doing in the other grades. So it's a think aloud, right? You're modeling the thinking, not so much the writing, a little bit if you need to. But I think we think together that, guided practice, and then you think together and you think alone. And again, as I said, there's times where you're going to have to go back. I do want to highlight resources on New Learn Alberta. So when you go into New Learn Alberta in the curriculum, there's that little I, and if you click on it, you get this tests on one part, but if you click resources, there are some, and what you'll see most of for grade 1 to 3 right now is these Pearson literacy readers that can support some of the concepts that they're learning, maybe at the explain phase. Grade 3 is where Gizmo starts. I know that they've talked about demoing it, but really this is an interactive, and it's a simulation of an investigation. My advice when using this is they are really good, and they're good for the scientific methods, is to do a lot of hands-on first, because this is an inclined plane, but it's really good to go in a little bit more depth. And the teacher version contains a student handout, teacher guide, answer key, and vocabulary sheet. But again, as with all resources, yes, they're aligned, and they will help develop knowledge, and they do an investigation. But again, it's an American resource. So look at the student handout carefully and just double check or work with that. Okay, so many of you are asking, are you sharing your slides and the handouts that are available? So in a moment, I'm going to drop in the chat a link to this handout. So it's a Google, it's like a PDF, and it's you can click on your grade, and then just it says like file, then you make a copy because you only have view only, so just file, make a copy, and you can get access to it. So what's in each of these is a sample lessons to introduce the scientific methods in September, about a week or a little less than a week worth of lessons, some assessment look for is connected to your skills and procedures for your grade level that I developed with the assessment consultant. And then there's a teacher definition for a scientific method. So the example was data today, so you can use that if you want to add to or make vocabulary terms. And then some graphic organizers or investigation templates that you can use in your classroom or use part of it. I will be having sessions coming up in September that focus specifically on integrating matter and the scientific methods. So, and then you will walk away with resources that you can actually use in your classroom to teach. It's not an entire full organizing learning outcome, but it's a development of cusps combined. So September 18th is grade 1, then 19th is 2, and the 20th is grade 3, and these are after school sessions. Okay, so whoops, actually, just go back here. So grade 1 is looking at how actions change the properties of an object. That will be the integration of matter and the scientific methods. Grade 2 is how the purpose of the object will influence the materials used. And then grade 3 is how matter can change states if heated or cooled. And grade 3, you have quite a few of those matter. Grade 1 is one cusp, grade 2 is a few, and then grade 3 is quite a few of those. Okay, so I hope today that you walked away with some key ideas that science uses methods of investigations to build knowledge and understanding of natural world. Each grade learning outcome and cusps unwraps deeper layer or focus on those investigations. And that there are criteria to develop those skills and assess them to help students prepare for the next grades. So I'm going to drop into the chat the handout for today so that you can use, I'll go in here. Ah, there we are. Just want to make sure everybody's got access to them. Again, you're going to have to make a copy for yourself. And there we go. And I'm just going to leave it open for some question and answer. Please feel free. I think if you have a burning question, someone else is going to have that question. And then you can and you can click the link to register as well if you would like for those sessions. And then yeah, go ahead, Ted.
I was just going to say there were a couple questions. You want me to read them that were a little bit further up?
Yeah, if I haven't answered them for sure.
Okay, yeah. What now? Just to clarify, though, the link that you sent has all the resources from today. Is that correct?
Yeah, it's this handout on the screen is exactly what they'll get, and it's if you hover it's linked.
Perfect.
So yeah, right here.
So will participants be getting an email with this, or this is the?
Yes, well, it's going to go up on the website, and the recording is also going out today. I'll drop the link again. I'll just make sure. I'll make sure I'm sending the right share. I'm going to make sure.
So I just want to clarify that. Just make sure that whether an email is going out to the participants or people can just download this.
Oh, I'm accidentally, you know what? I'm accidentally sending it to Stephanie. Sorry about that. Thanks, Stephanie, for letting me know. There, I put it back to everybody. And in there is a copy of the slides for today's presentation as well. Yeah.
So, Jonathan, that should do the trick, I think, then for you. Probably won't get it. So people will not be getting an email. Is that correct?
An email will be sent, but it's going to take a little bit of time. It's the recording of today's session. Everybody's session is going to be emailed out.
Okay.
And I just want to say a big thank you to everybody if you're signing out right now for coming today on August and joining the session and taking part in the interactive. Really appreciate it. Thank you so much.
Just a couple quick questions. Will there be any kinder sessions? But scientific methods is not a kinder organizing idea, but you may want to expand on that.
Yeah, the reason these are grade 1 to 3 is because there isn't an organizing idea for scientific methods, and that's kind of my focus with integration of that. But the computer science session is a good one to go to, because that could be where some integration can happen for sure. Absolutely. Yeah.
Some other questions you mentioned about sessions for September. There's a question about how will we hear about it, or will we get an invite for the sessions in September?
On this handout, it's linked to register for the sessions if you choose. So right here where it says grade 1 or grade 2, grade 3, and probably because you joined this session, you're going to hear about all the sessions, because I know that Chris and Ted also have sessions coming up too. So more than likely you'll get emails about those sessions as well.
Okay. Another question was regarding some of the scientific vocabulary terms and concepts. You and I talked about this, but a question was, is there something that's going to be made? I'm starting something, but you may have more information on that, and we'll be getting something out as soon as we can. But Nicole, you may have more information on a sort of a glossary of terminology and things like that.
Yeah, I mean, I did drop one in just to help everybody right now for grade 1 to 3, but it's not vocabulary cards, it's just terms with definitions. But yeah, Ted, we are working on that in the background, so something will get done, and I am focusing on the science methods as well. Yeah, for student-friendly stuff. Yes, for sure.
All right.
And yes, if you missed the session, yeah, the recording is going out to everybody.
But I hope I have everybody's questions. If not,
I think
maybe you can
so.
speak up.
Yeah, absolutely. Open up your mic. This is the time. Thank
There's
you again, everybody.
One question here from Laurel Young. I don't know how to, the link was sent yesterday from Ted